Good morning, everyone, and wake up. Thanks for getting here early for our session. My name is Guy Bowerman. This is Alan Stevenson.
Hello.
We're both program managers in the Azure Compute team, and today's topic is deploying and managing hyperscale applications on Azure VMs. You may notice it's a title change from what you may have looked up or even what's outside the door. So perhaps we should start with saying what we're going to be going through today. So we'll start with just a kind of a broad look at the cloud continuum. In other words, Azure offerings, third-party offerings from infrastructure as a service through to platform as a service. And we're going to kind of take a tour, working our way up from the initial building blocks through to some of the new features in Azure Resource Manager, and look at how what are the scale considerations at each level and how you can make use of some of the scale features that we have. Then we're going to finish by seeing how we can actually take the pain away, going up to a higher level and looking at tools where some of these scale considerations can be managed for you. That's the basic agenda. So I'll start with the big view. You could look at Azure as kind of a unified, consistent platform that spans on-premises, spans data centers, spans the Microsoft public cloud. Particularly now you have things like Azure Stack, so you've effectively got binary compatibility across the entire spectrum. And if you look at our core strengths, the core strengths of Azure, all of them contribute to a platform that's really good for deploying very large-scale applications. For example, in terms of openness, we've got full open source support. So you've got like more than 21% of VMs run Linux. The whole an entire open source stack up to platform as a service can be deployed on Azure. We've got a lot of partnerships with open source companies. Enterprise grade, so we've got security, compliance, role-based access control, full AD, identity support all the way through. It's really useful features for massive scale like e-commerce applications to have that just full enterprise grade security. Hybrid, so as I mentioned, we've got Azure Stack, so we've got full compatibility, but we've also got things like ExpressRoute and VPN, so you've got full hybrid connectivity between on-premises and the public cloud. And then hyperscale, you've got data centers in every region. You've got like 19 regions, hundreds of thousands of cores in each data center, so you've got massive scale there. Put those all together, that gives you a platform where you can really build on with very large-scale services. So if I start with kind of looking at a continuum from down low level where you control the networking, you control the storage, all the way up to platform as a service where your big concern is just deploying your application rapidly. What you tend to find is that up at the level of websites and app platform, concerns of scale, a lot of the concerns of scale get taken care of for you. And where we're going to focus in this session is the first three layers. So starting with virtual machines and virtual machine scale sets. We'll look at virtual machines, particularly with the Azure Resource Manager model, and what are the options for deploying like multiple virtual machines. How many people here are familiar with virtual machine scale sets? Okay, I was actually expecting it to be just me, but that's good. Hang around because we'll learn more about virtual machine scale sets in this session. And then extensions. Extensions are a very powerful tool for scale deployment. You don't have to bake in specialized functionality into an image. You can choose from a very curated selection of solutions like security, backup monitoring, and deploy these solutions when you're deploying the virtual machine or even afterwards. So basically, you can configure your virtual machines by script. You don't have to go make a custom image and then go change that custom image when you need to make a change. So extensions are a very powerful model down at the infrastructure layer. Then you've got Service Fabric. We're not really going to be talking about Service Fabric in this session, although there are some great sessions on it at this conference. But it really enables devs to build cloud services, very elastic, large-scale cloud services. And then you've got Batch, Things like Batch HD Insight, which lets you Batch lets you manage big compute workloads. HD Insight is really good for running big data type applications. So with that, I'll go in a little bit more detail and look at the choice that you have at really every layer of this stack. So as I mentioned, right down at the infrastructure, now you can choose between Azure Public Cloud and Azure Stack Private Cloud. This is really good for, say, developing on-premises and deploying to the cloud, for example. Or just if you've got some kind of global solution where it makes sense where your latency is good to be near a data center, and if you say it's based somewhere like South Africa where there is no data center, then you can have the same binaries running, deploy the same applications with Azure Private Cloud, the Azure Stack. I mentioned scale sets and extensions. Then, if you go up to the level of cluster orchestration and compute paths, again, as I mentioned, Batch, HD Insight, Service Fabric, you could say these sit at this level. Then you've got various open source solutions as well, like cluster orchestrators, like Mesos, RightScale, Swarm, Scalar, and then just general paths platforms like Cloud Foundry, OpenShift, etc. All of these run perfectly well in Azure, which allows you to make a choice at any level of this stack and find ways to run your applications at scale. I've just kind of highlighted here, we're going to be touching on in more or less detail all of the topics in orange during this session. Now with that, let's start right down at the bottom. We're going to look at some application scenarios and then go into what are the core building blocks of building at scale. So I'm going to hand over to Alan, and over to you.
Thanks, Guy. So one of the common questions that we get is, what types of things do people run at scale? And it's interesting because the actual answer to that crosses almost all verticals that we see. So in IoT scenarios where the devices don't actually have enough power to process things on their own, we see that data sometimes sent to the cloud to do additional processing, gives you analytics, decision-making, control of the world around you. In finance, we find people doing end of sort of period things, end of day, end of month, end of year. We also see people doing stuff like trade analysis. So how did they do on their trades for the previous day? Which things might be good for them to act on the upcoming day? In media, we see everything from things like rendering. When you watch movies, you'll see a lot of these things have special effects today, all the way through transcoding to ensure that various types of videos, you want to watch a cat video at home, has to get formatted for the screen you're looking at. So something has to be done at every layer. We're even seeing some transcoding done for live streaming. Oil and gas, they end up doing reservoir analysis when they see a new oil field, simulate oil well placement to see how they get the most out of the smallest investment. Realistically, almost every vertical we've come to has some use for computing at scale. Now, while there's a large number of these scenarios, there are actually fewer patterns that we see. The patterns are usually based a little bit more about whatever sort of constrains the operation. And this is a sort of continuum, but at one end you have of what we typically see. You have a lot of big data type stuff where your data is the constraint, and this is either due to your ability to move it around or size, and then what you basically do is you tend to move your compute power closer to your data, and that's stuff like analytics. Big compute is sort of the other end of that spectrum, where it's entirely CPU bound, and you tend to move your data closer to the compute. This is stuff like rendering simulations. We also see demand for stuff like microservices at scale, so things like using enormous number of containers on a large number of machines. So while there are a lot of scenarios and fewer patterns, they're all actually built from a very few basic elements: VMs, containers, storage. So how do you break this down? So your goal is most likely to run a workload or a service. As an example, let's say you've been doing some video transcoding. You've been testing out a process. Now you're going to need to transcode 1,000 videos. This is something you're going to have to do periodically. You could do this manually on a series of boxes, or you could make it easier and set up a system where every time a new set of videos come in, you simply submit it and it runs. When you typically set up these types of systems, one of the key concepts is to take your workload and break it down into pieces. These pieces are usually oriented around stuff like compute or storage or networking. And you end up with sort of a unit of work. And this unit of work is the unit that allows your process to scale out across machines, containers, storage accounts. In the case of the video example, you might choose one video as your unit of work. Scale units are in general things that are designed to be, individually managed, monitored, and then say a transcode fails for whatever reason, that they can be recovered and rerun independent of the other pieces. Typically, we see that people gauge these things to take a few minutes to a few hours for each individual unit of work, though some people use longer runs that include concepts like checkpointing. As you design, you should also consider some of the aspects of your environment. So whether or not you want to use the on-VM ephemeral storage versus, which tends to be faster, versus the blob VHD storage, which tends to be more reliable. Custom images, where you can actually include your data on the image versus gallery images, where those are maintained in general by other groups. Whether you want to scale up, so getting bigger VMs with more horsepower behind them, more cores, more memory, versus scaling out, which is simply allocating more and more VMs to throw at the problem. Though even with more VMs, you still need to think about the size of the VM and what fits your workload. You'll probably have a patching and security story that you have to think about. And this is starting to get into where a lot of the higher level services tend to have some of these stories for you. How will updates be done? By who? Are there any requirements that your group has for anti-malware, antivirus, etc.? And then, of course, there are some throttling limits. Our scale customers tend to hit those more than others. But these cover things like number of IOPS on a storage account. You can find all these things online simply by searching for Azure limits. Now that you have this sort of unit of work in mind, let's talk a little bit about how to go get a resource to run it. Historically, this is a shot from our older portal, you can see that cloud services were actually designed to be the scalable option for which were designed to power these rich websites. We did this through worker and web roles, which would scale up and down, creating effectively more VMs behind the scenes as needed. Due to the ease of scale, some of our higher level services today are actually built on top of these things, though they're a little bit limited. They only allow you sort of blank Windows Server roles. And we found that a lot of our customers want richer images with their data or binaries already included in the image, or that they want Linux or other things in there. And to get this, you need to move to IaaS, which gives you this sort of broad range of VMs and functionality, though doing that has been a little bit more difficult, especially at scale. And this is where stuff like Azure Resource Manager comes in, which will make your life easier. So here is Guy to tell you a little bit more about using it at scale and to show you the new portal.
Thank you, sir. So let's look at the new stack based on Azure Resource Manager. Let me just check how many people attended the IaaS deep dive yesterday. Just get a feeling for, actually not that many. What I'm going to do is a lightning tour of Azure Resource Manager, resource groups, and templates. Maybe like I'll take 2 or 3 slides doing this. I do recommend you go look at the deep dive, look at the replay of the deep dive. That was a really good introduction to these topics in more detail. But at the heart of Azure Resource Manager is the concept of a resource group. So pretty much anything you deploy in the new stack, you'll be asked for a resource group. And a resource group enables you to manage an application lifecycle as a single entity. You can define role-based access control rules scoped to a resource. Typically, any collection of resources that have a similar lifetime. So if you want to deploy them together, you want to take them down together, then typically they belong together in a resource group. Every resource only belongs to one resource group, so you can't have it belonging to multiple. And then these resources, they all have types, like compute, network, public IP address, storage. And there's underlying providers which then provide those resources. And the good thing about that is they can be provided in parallel. Where explicit dependencies don't exist, you can just say you want 40 virtual machines, you could go deploy 40 virtual machines. You don't have to serialize those in a cloud service. And the other thing is there's a declarative model-driven deployment. So you can write a template to describe your entire application with all the resources in it. What's nice about that? It's also consistent. So with Azure Stack, you can deploy a template in the same way. And there's other nice features like with these templates, you can do custom tagging, for example. So it's a nice set of features. And if you look at these templates, they're what's known as idempotent. You can reuse them. They've got parameters that you can pass at runtime. So you can have a generalized template. But also within the template, you can have all these sections within a template where you define resources and you can reuse them. And it's also, so that makes it very easy to orchestrate. It also makes it easy to roll back. Just deploy the template again with different parameters or different values. A template is effectively a source code file, so you can have it checked in and you can have version control. And then within the template, you can specify, with resources, you can specify specific dependencies and connections between them. So I will try and work through a very simple example of that. I say try because I've tried to make this as easy to follow as possible so that when you then look at a template, it actually makes sense. So as I mentioned, you start with a resource group. What we're going to do in this slide is build a virtual machine. So you start with a resource group, and then you can define things that don't have any dependencies. These can go get deployed first. Virtual machine doesn't have to have a public IP. It could just have a virtual IP. It could be connected from a load balancer, or it could just be inside the VNet that it's going to be deployed in. But you can give it a public IP so it directly connects to the internet. You can define a virtual network and a subnet. You define storage. So you can effectively define all of these or deploy all of these in parallel. And by the way, on the right, this is what the name of the resources look like in the template. So public IP address, virtual network, storage account, network interface. And sorry, I could probably point at both screens in this room. And then, so you've defined all these things. Now you can define resources that depend on them. So here I'm defining a virtual machine, and this virtual machine requires a network interface code. In fact, let's go back. The first dependent resource is a NIC. So that depends on an IP address if you want one, and it always depends on a VNet. Everything has to be inside a VNet. And then you can define a virtual machine which depends on that NIC, and it depends on storage. So that way you've built up a definition of a virtual machine which you can deploy. If you look here in GitHub, we have a whole collection of templates of JSON-based templates which deploy different types of applications. This is one of the very simple ones, which is just a simple Windows VM. If you look there, you'll see basically exactly the same build-up to create and deploy a virtual machine. It kind of looks like this, and I'm not sure if we have Zoom here. Probably not. It's probably a bit of an eye chart, but that's okay because I'll be highlighting some specific points in when we demo this. If we look at the one in GitHub, that's the one I just showed a link to. You find the README comes with a Deploy to Azure button, which then takes you straight into the new Azure portal. So it's a very nice deployment experience. You can go to GitHub, you can take those, you can fork that repository, make your own versions, you can reuse any of that code. So that's the basics of deploying an application, but I haven't really said anything about scale. So now let's talk about some of the scale concepts within Azure Resource Manager and when you're writing a template. One thing you could do is you could just have a collection of virtual machines, but that's not very efficient. there is the concept of a resource loop, which lets you repeat certain definitions within your template. So here I've got a definition of a virtual machine, and using a resource loop, I can just have a loop of 2 or 10 for the components that I want to repeat. So I can have repeating VMs which depend on this resource loop of NICs, which depend on this resource loops of public IP addresses if I'm using them. Similarly, I could scale this out wider. I could have multiple subnets. I could use a resource loop to produce multiple subnets or multiple storage accounts. So let's look at how this works. For every resource, you use a copy loop to set the number. So in this case, hopefully it's visible at the back, creating 10 NICs. So the copy loop, you set the count to 10, and for the name, you use copy index to create the name. So it's going to be NIC 0, NIC 1, NIC 2, etc. And then when I'm defining a virtual machine, which depends, every virtual machine depends on a NIC, again, I'm creating 10 virtual machines, and I have a depends clause. Let's wander over to this side. I have a depends clause which depends on this NIC with the copy index. So you can use the copy index in the depends clause. So that way you can create multiple resources and then multiple resources which depend on those resources. So you can use this to build up people. You'll see some examples where people are creating like 40 virtual machines this way. So it's pretty useful. Now I'm going to show you what that looks like. So this is just a repository I created where I've got some templates that I'm going to be using today. And this template, it basically creates a Mesos master-slave configuration based on CoreOS VMs. So here, I've got a group of slave VMs. I've got just one master VM. And when they come up, they're all going to connect together. So I'm going to start by deploying it, and then we'll actually look at some of the details. So when I click the deploy button, it then makes a connection to the Azure portal. So, and then it shows you the template that you can then edit. And before I actually go through what's in the template, I'm just going to deploy it so that while it's deploying, we can then talk about it. But it's a very nice, I mean, obviously, I would probably, typically when I'm in my office, I use something like PowerShell or the Azure command line interface to deploy templates and to write scripts. But this is actually, if you're just doing one, and you just, or you're showing it to people, or you're just comfortable with working inside the portal, and this is a very nice level of integration that I can go directly from GitHub. So I can save this template. I can then edit the parameters. So number of slaves, I can put 20. Region, it gives me a drop-down, which I've defined in the template, which I'll show you. I'll put East Asia. I've got my subscription. I can create a new resource group. So I'll just create a new resource group. I'll call it Guy Ignite Demo. Hopefully I haven't already got one of that. And then, oh, sorry, hang on. I was supposed to click OK on the parameters. So then I'm going to select a resource group location, which I want to be the same as my VMs, although it doesn't have to be. So I'm going to select East Asia. And I can go ahead and create it. So while that's deploying, let's go back and look at what that template actually does. So this was the one. And would it help if I zoomed in a little bit? So this is where I define the parameters. So since this is a Mesos configuration which has a master that connects to a bunch of slave VMs and it can then deploy applications on top of them, as a parameter I have number of slaves. I don't know why I'm pointing to my laptop, just except I'm pointing to the right place on the screen. And then you saw that there was a drop-down of, you saw that the region had a drop-down, and this is how you say default value, you say allowed values. Because this is a demo, I actually defined a lot of variables. You could also have these variables defined as command line as parameters as well. So sorry, hang on. Having trouble with the zoom it. So various variables which some of these are like I've got a public key here. Some of them are pointers to scripts which run the Mesos configuration when the VM starts up. If I looked at if I go down, and what I'm actually really interested in showing here, though, is the resource loop. So I'm going to scroll down to the slave virtual machines. So here's an example, and I'll just zoom in. So here, I declare my virtual machines, and then I have the name. It's going to be slave copy index, so like slave 0, slave 1, etc. And then it depends on the slave node NIC. So I created a load of NICs for these in a resource group above that as well. So that's basically how it works. And if I go back to my, I see I spelled demo wrong, so at least that means I've got a unique resource group name. And if I go back here, it has already deployed. So right now I've got the master, I've got a set of virtual machines. They've all deployed and they're ready to go. And in a few minutes, I would be able to go to the IP address of the master, port 5050, and then see all those slaves. So I'll actually be coming back to this in a little bit. So for now, back to the slides. Thank you. So using a resource loop is great for scaling up to, let's say, about 40 virtual machines, if you're just like reproducing NICs and virtual machines. But if you want to scale to hundreds of virtual machines, then you have to think a little bit, you have to take care of more things. So one of those things is storage accounts, because you're limited to 40 disks per storage account. So if you had 2 disks per VM, then you'd be limited to 20 VMs, for example. So also, you don't want to manage large numbers of IP addresses. Typically, you'd use a load balancer so connections can be routed from a single public IP. So now you're getting to a scale where you really have to start thinking more carefully about the design. In this example, we could use a resource loop to create multiple subnets. We could still use one subnet and one VNet, but we could use a resource loop to create multiple storage accounts, and then within that use resource loops to create the virtual machines, have a load balancer, and a public IP. So a typical slightly large configuration would look like this, but you can use the same techniques effectively. What if you want to scale further? What if you want to scale to, resource loops don't really scale to thousands of VMs. You'll run into issues like throttling, things like that. You'll also run into subscription limits. Virtual networks limit you to like around 2048 VMs. They also limit you to a single region. So if you wanted a large application, then you'll consider creating multiple VNets, for example, and you'd have a traffic manager directing your traffic to specific regions. In fact, this diagram is from a real customer we're working with to create a very large-scale e-commerce application. You have a traffic manager going to load balancers. When I say containers, I'm sorry, the printer's a bit small, but when I say containers here, I don't necessarily mean containers like Docker. Containers could be VMs to contain the workload, or they could be containers like Docker containers inside VMs. At this point, it doesn't matter too much. In terms of this diagram, the work is running in a collection of containers. These clusters of containers then, traffic managers are being routed via load balancers. And you typically have some kind of event hub, which then routes data like metrics, data to alerting agents, to auto-scaling, to logging. In this particular example, it's doing things like resizing images at a very large scale. So you'd have a cache. You'd have things like an image cache. And then below that cache, you'd have storage blobs for cache misses. And you'd typically have a VM managing the entire configuration as well. In this case, it's one based on MongoDB. So there's a lot of open source in this. And this is the kind of concepts you have to think about when you build up to very large scale on infrastructure as a service. One of the things that can help you when you're doing this is making use of containers. Now, there is a session specifically on containers and Azure later this week. Is it today or tomorrow? Tomorrow. Where you can go into this in more detail. But containers let you abstract the unit of work away from the virtual machine. That gives you some advantages. In some cases, it's absolutely appropriate to just run your workload in the virtual machine. But suppose your workload is actually less than one VM, even a small VM, or you want to deploy fewer VMs. So you deploy one large VM, you have a collection of containers running in that. Containers are very lightweight. They're very fast to provision. So you can definitely use it to increase density. It also can also simplify application updates, because then you don't necessarily have to make changes at the VM level. You can just make changes, update your container instead. And so you can work on the latest container and then have deployment mechanism to deploy your containers. So they also work with cluster managers. And so you can manage things like autoscale. There's a variety of cluster managers that you can use to then manage your containers in the same way that they manage VMs. So there's a lot of potential advantages. In fact, let's just switch back over to 7 for a second. That Mesos cluster that I deployed, this is one. What I could do is I could go find the IP address of the master, go to port 5050, but this is one I'm actually going to use in the next demo, where I did the same thing. I used a template to create this, and when it came up, when I went to the IP address of the master, it says it found 30 slaves and activated them. And then if I go here, these are all slaves that basically they just came up when I deployed my template. Now, they're all connecting to each other on the virtual network. I didn't create public IP addresses for these slaves, so they're all inside the virtual network, but they had the script, they had custom script extension to go connect them to the master. So I have a fully working Mesos configuration just by deploying one template, and it's ready in minutes. If you compare that with the older cloud service model, if you're using IaaS VMs, operations within a single service are serialized, and it could take you much, much longer to create 30 virtual machines. We're talking potentially hours. So, or suddenly, close to an hour because they're serialized operations. This just, if you wait around 10 minutes, and that includes about 5 minutes for the Mesos configuration to get going, then you see it. Which one are we? 1?
5.
5. Everything that we've talked about so far, you can go away and do right now. Well, actually, prefer if you waited to the end of the session. But you can. It's all there. It's all out there. You can go to GitHub. You can look at our Azure Quick Start templates. You can go play with this stuff. What I'm going to talk about now, though, is something that we haven't released yet, but I think Mark Rusinovich did announce it last week, and we've made mention of it, which is virtual machine scale sets. So this is a feature that's coming, and it lets you manage groups of identical virtual machines. One of the things it's very good at is autoscale. So you can simply change the instance count, and scale sets will increase the number of virtual machines evenly across update and fault domains. It's also very good for performance. You can deploy hundreds of virtual machines, and that just results in a single call down to the underlying fabric. Whereas if you use a resource loop, you could have potentially hundreds of calls down to the underlying fabric. So that allows us to make optimizations. So there's inherent performance optimizations there, so you can deploy virtual machines faster. And as long as you use up to the number of supported virtual machines, then we take care of concerns like throttling, and you don't have to kind of plan for concerns like throttling. They support custom virtual machines like Windows and Linux, and it really makes management easier. So let's look at, in the same way I built a VM, let's build a virtual machine scale set and see how it looks. So first I create a resource group and a subnet, just as before. Now I create a scale set, and I set the target instance count to as many VMs as I want to. And then we have the concept of a scalable NIC and scalable storage. What that means is you don't necessarily need to have to go and define them all yourself. You don't have to think, how many storage accounts do I need? So this is the direction we're going, which will be you can define the concepts of the storage and the NIC within the VM scale set, and then just go deploy your scale set, have a lot of these things taken care of, and deploy it very efficiently. So that's currently, look for more announcements about this, and if you're very interested in this, come and talk to me. And it's certainly, as I will show you, I'm already putting templates that deploy scale sets out on GitHub, except that for now there's only a few whitelisted accounts that are actually running it, as we're still working on this feature. That's where I've actually put a few. You can see a few example templates here, Azure Myriad, and you can see it'll give you an idea, but the syntax is not finalized. We haven't done all of the work on like scalable storage, scalable NICs yet. There's more to come, but I'll show you a bit what it looks like. So you specify a target instance count. So you say, in this case, I'm saying, okay, I want 40 instances, so I just put 40 in. I have this resource type virtual machine scale sets, and I put 40 instances. And then when I'm going to configure my storage, for example, there's just a parameter called public IP address name prefix, for example, if I wanted all of these to have IPs. So, and there's a name prefix for the network interface. So similarly, you just use a prefix like that. So it's kind of reminiscent of resource loops, except that it's all built in. The infrastructure recognizes what you're doing. You're not just sending a load of calls to it. So let's take a quick look at that. I'll switch to 7. And I will go back to my GitHub repository. And here, I'm going to scroll down to VMSS scale in. In fact, I'm just going to show you, I'm going to go click deploy to Azure. What I want to do here, and I'll show you basically this cluster. I actually built this cluster using a VM scale set. So it's a regular VM, the master, but the slaves, I just deployed a scale set. I set the target instance count to 30. But suppose your application is monitoring the resource usage, and you find you actually don't need 30. You don't want to be paying for 30 VMs. You want, say, 15. Then it's very easy. If you want to scale in and just have like 15 VMs running, how do you know which ones to shut down? With VM scale sets, it makes intelligent choices for you. It keeps it balanced across update and fault domains. So if I go back to, here's my template. You'll see this is a very simple template. I've got my parameters, which is the instance count and the location. But that's all. If I look into resource groups, into resources, I've got virtual machine scale sets, and I only have one setting, which is target instance count. Because I'm scaling in, it doesn't need any more details. I can just put a number like 15 and deploy it, and it will take those 15 VMs away. So let's go and do that. So here's my parameters. So this time I do have to remember the correct resource group name because it's one I created earlier. So I'm going to put that. And then instance count, I think I said 15. Location, East Asia. And then I select my resource group. And I can go deploy it. So that's just a very simple way of scaling down. Now you can imagine integrating that with autoscale. Your application can just go deploy that template very easily. Now, it'll actually take a few minutes. When it shuts down the VMs, it will take a few minutes for the Mesos to kind of get a heartbeat with the slaves and realize that there's only 15, but it will adapt automatically. So it's just a really good way to scale down. So I'm going to switch back to 5. So just to summarize how this all fits together, if you use application orchestrators, then as your application or service grows, you can just very seamlessly grow the number of containers and very seamlessly grow the number of virtual machines as you scale out, as you scale down. So this is kind of the vision we're heading towards, where you can be operating at a level of infrastructure as a service, but you've got more and more of these concerns being taken care of for you. So that then you truly get a type of basically infrastructure as a service at a very large scale. So, yep. One other thing, though, is let's move up the stack a little bit and figure how can we make life easier. You do always have scale concerns with infrastructure as a service. So we have various offerings, various products that can actually help make life much easier to run at very, very large scale. So I'll hand over to Alan, who's going to talk about that.
So we just to briefly cover what we've gone over. There were a number of these items that we had touched on. So starting from the bottom, the cloud, scale sets, extensions, and then you saw Mesosphere, which is one of the open options on the left there. So I'm going to, these are easier forms of IaaS, but things can get even easier with some of the higher level services. Now for the services I'm going to go over, there are longer talks on these services, so I'm going to be just touching on a couple of them briefly, and I'm going to cover sort of overview of them. So why do you want higher level services? Your goal is to run a workload or a service. You don't necessarily want to manage all the infrastructure. And between you and the sort of layers of VMs are a lot of additional tasks. There's everything, while provisioning and deploying resources, sort of step one, you then need to manage those resources. Scaling up and scaling down will be easier with VM scale sets. But you still need to install your binaries if they're not on your image, handle the individual units of work, getting them on the machine, getting them running. There's what happens when an error occurs. This is actually some of the more complex code in terms of how do you recover, how do you manage, especially at very large scale. You will occasionally have VMs that go down. So overall sort of workflow and resource management. Basically everything in orange and yellow there. Higher level services in general do a lot of this for you. They take your units of work, they assign them to machines, they manage them, monitor them, and if anything goes wrong, they simply will rerun those pieces and keep going. Now, you have some, we've talked a little bit about some of the open offerings. There's also some of the more traditional sort of HPC style job schedulers like PBS, Torque, and Grid Engine that you can run and that people do run in the cloud. But we also offer things like HD Insight and Batch, which are the two that I'm going to be covering. And then we have others like Azure ML that does specifically stuff for R. So there's a number of those specific services, and Media Services does a lot of video work at scale. Unlike some of the more traditional job schedulers, the things that are in the cloud are designed for the cloud. So they're not sort of focused on how you schedule against a limited set of resources. Part of the promise of the cloud is this elasticity of how many machines you have. So they're designed with that in mind for a better experience. So let's start with HD Insight. HD Insight is a way to run Hadoop clusters in Azure, including the ability to have the new Yarn scheduler. Hadoop clusters sometimes will have a higher overhead. So HD Insight will basically is a service that will manage that cluster for you, manage its lifetime, makes running Hadoop clusters in Azure easy. This is one of the examples of Microsoft supporting some of the more open standards concepts. The implementation of Hadoop they run is not unique. It's not specialized. It's simply same as any other, and they just manage the cluster and the sort of underlying infrastructure, and then you decide what your workload is. A lot of their scenarios are around stuff like big data and analytics. Though they support a variety of things, including MapReduce, real-time streaming, and NoSQL databases. This is one of the types of services that, as I had said earlier, initially built on the cloud services, but is moving to Azure Resource Manager because of all the additional benefits it offers to our customers. And that, in fact, their initial offering on that is already in preview. You can go sign up for it today. Stuff like HD Insight is designed to scale up to hundreds of nodes. And one of the things that you'll hear sometimes in demos is nodes versus cores. If you think of a node as a VM can have 8, 16, even 32 cores on our new large G5 VMs. So hundreds of nodes can be thousands of cores. One of the other services that we offer that is designed to go to much larger scale is called Batch. Batch is designed to run sort of any code at scale. Very highly variable workloads. It tends to be much more compute intensive. We also, though, see some workflow management coordinating other services. But there's a lot of things like rendering, and some of the other rendering and scale demos you may have seen in the past 6 months have been on Batch. They also handle a lot of things for you, like installing applications for you, get the tasks on the machine, handling users. Once again, this is a service that is initially built on cloud services. They are, once again, moving to Azure Resource Manager. That offering will be coming up in the future. And this one is designed to scale up to thousands of machines, or even tens of thousands of nodes. And so you can add, an extra 0 or so to that for number of cores. To give you an idea of what this looks like, I'm going to show you a demo of the Batch service. So, what I have here is a sample application which does OCR, and on the right here is a heat map from our Batch Explorer sample, which is a sample that has a bunch of built-in functionality for using the Batch service. You can see that in these there's 75 VMs here ready to go. I'm going to go ahead and start the task over here, and we're going to talk about it. Also, because it sometimes takes a few minutes to get things, we've been talking about hyperscale, but 75 VMs is not really hyperscale. So we're going to go ahead and take this pool and resize it up to 2,000, which will take a couple moments. Because getting that many VMs is not instantaneous. The nice thing about something like Batch is that when you're doing something like a resize operation, this is part of where you get the benefits at the higher level services. The actual resize of a pool, going from 75 to 2,000 is basically just a single line of code. So we're going to go ahead and hit continue and let it go through and do that. So, as you can see, that on the right here, all the things went from white to green. That's because Batch scheduled up all the jobs. You can see there are 130 tasks listed over here on the left. It's running 75 of those already. And then 55 left in the queue. What this is actually doing is it's going through and taking a series of files, and this is the type of scenario you may have, that need to be OCR'd, and running each one on a different VM. And then as the first document finishes, it will go and queue up the next one and keep cycling through until all the work is done. This is the type of system that you would probably want to have up and running if you were doing, once again, like the video transcoding or some of the other examples. We could have picked a shorter workload that would have, you would have seen a lot more flashing of, I should reset this to 1 second so you'll actually see that. But we could have picked something that had a shorter cycle time so that you would actually see a lot more flashing as it's scheduling work to nodes. But even now, you can see that the jobs are completing. We already have 13 tasks completed. And it's just assigning the new work as needed. And they're the, now we're actually starting to scale up as well. So we talked a little bit about, getting to larger scale. You can see that we're actually going up in terms of number of VMs here. So I'll let that run a moment and allocate, and we'll come back to it. One of the things I wanted to also talk about briefly is example of the type of service you'll see on this. So, example of type of service we actually do have is media services. Media services is one of the things that does offer transcoding as a service, used by MSN, Xbox, Office Video, Skype, and others. Their scale unit is actually one video. They have this focus on video, so they use batch to do the underlying pieces for them. Once again, if people schedule 1,000 or 10,000 videos, they simply schedule up that many tasks. As their queue gets too long, they do exactly what we were doing there, which is go say, I need more VMs. And those VMs come up and start up. They install their batch, takes care of installing the transcoding software, the codecs, and all the other pieces for them. So all they have to do is just continue to schedule work. And all the VMs will work the same, very much like scale sets, actually. But then it handles a lot of the job management, error recovery. And it allows them to sort of focus just on what they want to go do, which is doing video transcoding. If we go back to this, you'll actually see that we've gotten up to almost 2,000 VMs. But this is an example of where I said the big number of things that you see in demos is cores, not VMs. While we spun up 2,000 VMs fairly quickly here, and we're actually up at a steady state where we have all 2,000 VMs already, they're just booting up. These are currently 1-core VMs, but they could just as easily have been 8-core or 16-core VMs and represent 20,000 or more cores for actual use. And that's part of the promise of the cloud, is that ability to sort of go from the small to the large. And if you want to go to the next level, because this is a hyperscale discussion, we do have customers, and I have a screenshot from one of their demos, or one of their runs here, where they were actually going up closer to 18,000 VMs. Once again, same application, Batch Explorer. This is what it looks like when you're truly doing stuff at enormous scale. This is also within a single region. If they had decided to go cross-region, they could potentially have gotten a much larger number of VMs. But scaling is one of the promises of the cloud. In summary,
actually, before we go there, I think I might switch back to just see how the Mesos demo is doing, since we have some time.
Okay.
And, so, if I go back to where I did those deployments, if I look into my portal, you have to put your. So it looks like I did have one deployment failure, which is a disappointment. So something went wrong with my VM scale set when I scaled down. So I'll have to look into that. One good thing is that there is fairly good built-in error handling in the actual in the portal itself. So if you see a deployment failure, you can go in, you can take a look, and it usually gives you some information. And it looks like here it said the virtual machine profile is missing. So in this case, I think what I may have done is put in the wrong, the name of a non-existent resource group. But the good thing is that you have that link to the error messages there. So the other thing that I was going to show is if I create a large deployment with a VM scale set, I can go see that deployment. I can see the resource group. But what you'll see is, if I go and look at this VM scale set, it doesn't show any virtual machines yet because the portal doesn't recognize VM scale set yet. That's a level of integration that we'll build in. So the deployment works just fine. It sees the it has the concept of, it sees an availability set, it sees the NIC, but what it doesn't see yet is the actual VM scale set. So that's something that as we proceed, we will see it. So with that, I'll switch over to a basic summary where, as we worked our way up from basic building blocks all the way up the stack, where you can just press a button and deploy 2,000 virtual machines, you can really build anything, any kind of large-scale application on Azure. You just basically where you pick the level, and then there's a choice to deploy that large application. And hopefully we've gone through some of the considerations that you then have at each level. So with the resource manager, templates, you can use functions like copy to help scale repeatable resources. Scale sets is a feature that's coming soon. It will very much simplify auto scale. And then you've got higher level services like batch, HD Insight, which makes things a lot easier while you can focus just on the application logic.
Yes, you can deploy 2,000 VMs on stage with confidence.
Yep, that's good. And I've added a few links to other sessions where you can go deeper into some of the topics that we've been looking at. As I mentioned, the one at the top, the deep dive into IaaS capabilities, is where you can go much deeper into those templates, watch the replay of that. So we have a few minutes left. Happy to take any questions. Anyone got any questions? Yes.
So with Azure Stack coming, in theory, we should be able to do the same thing on-premise and then do it in the cloud, obviously.
Yes, that's right. Because you've got that binary compatibility, the compatibility goes down all the way down to effectively the fabric layer, where the fabric is obviously different on premises versus public cloud. But sorry, I should repeat the question. You basically asked, with Azure Stack, can you do the same things in terms of what we've shown you? So yes, you can. Yes.
So with scale sets, you mentioned Mesos Frag will handle when a node is shut down. And
Yeah.
but assuming you're not using a custom technology like that, you want to do it gracefully, maybe have a blocking API call to allow a node to finish something that it's doing before it shut down or remove itself from the load balancer or something like that.
So,
Be an option.
Did you want to take that?
yeah. So
Can you repeat the question?
The question was, whereas Mesos will handle some of the system shutting down if you're not using one of those higher level things, whether you should have some sort of calls to understand whether or not things are done doing work, and that's once again, like if you also look at services like batch and HDI, that's a similar thing where when they scale down, they can actually scale down the nodes. Guy had talked about with VM scale sets scaling down. One option is by sort of fault tolerance. The other option is to scale down as work finishes on a node. But yes, that's something you would, if you're not using one of those sort of orchestrators or work or resource managers, that you would probably have to do yourself.
But I guess what I'm asking is, that, would there be a hook in there somewhere that where you could provide a script call or something?
So with some of the higher level services like batch, we actually provide simply a formula that you just go put in there and say, as jobs finish, scale down. And that's all it takes.
But I think are you asking at the kind of if you're managing it yourself at the lower level, like infrastructure as a service? So yes, one thing we will be doing is fully integrating with Azure Autoscale. So there are hooks inside the virtual machines. They will be aggregated by Autoscale. So you can make direct use of Azure Autoscale to scale up and down. So that's coming. In fact, VM scale sets plus Azure Autoscale is going to be very, very powerful. But you can get that information yourself as well if you want to manage your own scale up and scale down. Let's suppose you've got your own Autoscale. Then yeah, those hooks will definitely be there. Any other questions? Yes. Yeah.
First one is, how can I migrate my existing workload, virtual machines, in the old model of Azure to the new model? Is there a way without destroying everything and creating all this stuff?
Yes, that's a very good question. When you say the old model, are you using like infrastructure as a service or platform as a service?
Infrastructure and cloud services. So I'm referring to the resource manager stuff.
Right. So I guess the question is, are we going to provide any tools to like so you can convert it to templates. And we're definitely working on guidance to help you do that. I don't know if you wanted to jump in, Madan, with any additional. But that is a very good question. A lot of people will be asking, like, okay, you're saying how great this new service is. How do we migrate? So you had another question, sorry.
Second one. It's very common in our customer scenarios that the same subscription has multiple workload and application farms. So you said that a single resource can be associated to just one resource group. And
Yeah.
I was thinking about VNet and storage account. And we have VNet and storage accounts that are shared among different application farms inside the same subscription. So is this still possible with this new model or something is going to change?
I see. So I guess the question is, can you reference a resource created in another resource group? So you want to create a VNet, and then you've got some other resource groups that you basically want to make use of services in that VNet. And yes, that is possible. Yeah, you can make references to things like VNets. Any other questions? We'll be hanging around for a while, so you're welcome to just come up and chat and ask us questions. So with that, thanks a lot for coming. Thank you.